My dear students, this is the second problem I have given as a homework. So this is the problem. Y of t equal to r of t plus 1 minus r of t plus r of t minus 2. So whenever you find r, immediately you will think about a ramp signal. Okay, a unit ramp signal. Right. So we'll see how to draw each and every part of this y of t individually. Okay, let's see. Look at this general ramp signal with the syntax. So x of t is equivalent to at when t greater than or equal to 0, 0 when t less than 0. So if you put a equal to 1, so it will become, when you put a equal to 1, it will become unit ramp signal with the symbol r of t. So the syntax become r of t equal to t when t greater than or equal to 0, t less than 0, right? So the only change in the common x of t is you are replacing a with the 1. So that is the main difference between your x of t and then your unit ramp signal. Okay. So just come to the problem. So you have to draw r of t plus 1. It's very simple. So r of t plus 1. So r of t plus 1. So vary from t with respect to t. So this is 0. So as usual, t plus 1 equal to 0, t will be minus 1. So your signal starts from minus 1. Okay. So this is my minus 1, this is my minus 2. So original r of t is like this. So your signal will start from here. Okay. Right. So this is your r of t plus 1. Right. So anyhow, we have to understand. So this is the amplitude of minus 1 is 0. Amplitude of 0 is 1. Amplitude of 1 is 2. And then amplitude of 2 will be 3. It is slightly changed from the original signal when signal starts from 0. So if you replace a with 1, so it will become r of t, right? So it will become r of t, right? So it will become r of t. So you just look at here. So 0, it is 0. 1 for the time period 1. So you will have amplitude 1. For the time period 2, you will have 2, and so on. So it is slightly changed. So you have to observe this point initially to perform this arithmetic operations like minus and then plus. Okay. So now you have drawn r of t plus 1. So now you know that what is r of t. So anyhow you just draw r of t will be this is t. So your r of t will be like this. So anyhow, for better understanding, you just keep this dotted line for a while, and then once you're familiar, you just forget about it. Because you will forget definitely. So what is the value of when t equal to 1? What is the amplitude value of t equal to 1? So you have to remember. So try to do this dotted line practice. And then we go for r of t minus 2. R of t minus 2. So as usual, t equal to 2. So your signal starts from t equal to 2. So here 0, then 1, and this is 2. So your signal starts from here. Right? So this is your r of t minus 2. Right? So one thing actually I forgot. Here I forget the minus term. So that's all about r of t minus 2. It has plus, so no need to worry about plus. Okay, this is minus. Okay. So anyhow, we just keep this r of t as it is and then subtract with r of t plus 1. Anyhow, for practice purpose, so you just draw the minus r of t is a very good practice. Right. So it is started from here and then not big change. Right. So this is t. So the amplitude value of 1 will be minus 1. Then amplitude value of 2 will be minus 2, and so on. That's all. This is the main change. So the amplitude value of when t equal to 1, what is the amplitude value? 1 here. And in this r minus r of t, what is the value of when t equal to 1? T is minus 1. This is minus 1, right? So when t equal to minus 1. So this is the main difference between r of t and minus r of t. So anyhow, keep this minus r of t as it is. So we'll combine all these three signals. Here I have drawn and then combined everything, right? This is our three signals. This is my first signal, this is my second signal, and this is my third signal, right? So individually we have seen in the previous frame, and then I have combined here, right? To understand what is actually happening in this y of t, okay? So my signal is started from minus 1 to plus 2. So my signal period is started from minus 1 to plus 2. So from this relation, so you can see this is minus 1 and this is plus 2. So when you equate to t plus 1 equal to 0 and my t minus 2 equal to 0, so it will come minus 1 to plus 2, right? So we have to concentrate this minus 1 to plus 2. This is the area of interest actually here. So we don't want to go for beyond this plus 2 and then less than this minus 1. Okay, we'll start here. So this is minus 1 at the first signal. We just see the minus 1 in the second signal, 0. So here also 0, here also 0. So there is no value here. So this is also 0 here. Okay, so you just refer the previous video. So how I wrote all the things. So when t equal to minus 1, what is the value? So what is the value here and how to combine? So what is the value here? Minus 1. So when t equal to minus 1, what is the value? 0 plus 0 plus 0. So there is no value. That is why I represent it as 0 here. So this is the flat line which represents 0. Okay. Right. And coming to the second, 0th point. So this is the 0th point. Just look at the 0th point here. So here we have 1 here amplitude. So just write 1 for t equal to 1. Oh, sorry, t equal to 0. Am I right? Okay. So for t equal to 0, it is 1. And second signal, t equal to 0, it is 0. Okay. And then here also t equal to, when t equal to 0, it is 0. So the value is 1. Right? So my value is started from 0 to, vacant from 0 to plus 1. Okay. So 0 and plus 1. Okay. Right. So and then go to the next step, 1. So when t equal to 1. So what is the value here? What is the value here? When t equal to 1, what is the value? 2. Right. So I already told you about this. Okay. So this is 0, this is amplitude level is 1, then when you move further, just increase the amplitude value plus 1. Okay. So when t equal to 1, so your amplitude value of r of t plus 1 is 2. Okay. And then here your amplitude value at t equal to 1, here what is the value? Minus 1. Right? Minus 1. Put minus 1 here. So anyway, plus and minus will become minus. Okay. And then so what is the value of this one? Plus 1. Here 0. Okay. So this will become 1. Okay. It still maintains up to here. Still it is 1. So the output I have drawn from 0 to 1. So I am switching over from 0 to 1. Right. My value is still 1. That is why I represented up to here. So and then go for 2 plus 2. Okay. So when t equal to 2, your value become what is the value here? So already you know that 1, 2, and then it should come 3 plus here minus 2, right? Minus 2, and then here you check it out here, and then what is the value of 2? Still 0. So still maintain 1. That is why it is maintained up to here. See, our value of 1 is maintained 0 to 2. Okay. So we can put it in some other way for your understanding. Just if you can understand, please also refer this. See, this signal is totally out of phase against this one. R of t plus 1 is out of phase with the minus R of t. So it will cancel each other. So up to where? So the sudden changes here appears up to third signal 2. So it will cancel each other up to 2. So that is why I represented here. Maintain only 1. It maintain up to only 1. So maintains one value up to 2. Okay. So this is another way to understand. But anyhow, we have a conventional method or traditional method. You just follow this. So this will not confuse you. So when you go to the t equal to 3, just imagine here we have carry forward from here 1 plus 2 plus 3, and then next one is 4. This will again minus 3. So look at the t equal to the point t. So here 0. So suddenly it will become 1. Okay, sure, it will become 1. Okay. So 4 minus 3, 1. 1 plus 1, 2. Okay. Now it is moved to. So our third point will move from 1 to 2, amplitude level from 1 to 2, so and so on. Even if you want to go further, so I put a dotted here because that's all. This will increase gradually. Just check it out here. T equal to 4. So when you put the t equal to 4, again this will come 4, and then this will become minus 4, and this will become 2. Alright. So what is the value here? 4 minus 4, 1 plus 2. Okay, 3. See here, 1, 2, 3. Again it will become 4. Okay, 4 and then 5. That is why I put it. Suppose 4 will come here. So it will come here. And then for 5 it will go as long as you put the value of t. Okay, so this is the resultant figure for the input value a of t, this one. Okay, I hope you understand. We'll see the next video very soon. Thank you very much.